This is the EdExcel AS Level Maths Paper 2 from the October 2021 series, and in this paper we will be taking a look at the statistics section. Question number 1. The Venn diagram, where P is a probability, shows the three events A, B and C with their associated probabilities. For part A, we have to find the value of P. First of all, we know that probability adds up to 1. So we've got the 0.2 plus 0.2 plus the 0.1 plus the 0.2 plus P. This is all equal to 1. We have 0.7 plus P equals 1, and so therefore P is equal to 0.3. Now for part B, we have to write down a pair of mutually exclusive events from A, B and C. So first of all, mutually exclusive means the events cannot happen at the same time, and so the events which cannot happen at the same time will be A and C. They don't overlap each other. So for part B, events A and C are mutually exclusive. Question number 2. The partially completed table and partially completed histogram give information about the ages of passengers on an airline. There were no passengers aged 90 or over. What we have to do for part A is complete the histogram. Well, first of all, with a histogram, we know that frequency density equals frequency divided by class width, and we can also rearrange for the frequencies here or the class width. Now, what I will do is focus on the different intervals and see what I can calculate from there. If I take a look at the first interval, 0 to 5, the frequency is 5, the class width is 5, and with this I can find the frequency density. So for part A, if I focus on the interval 0 to 5, frequency density is equal to, well, we have a class width of 5, a frequency density of 5. So we have 5 divided by 5, which is 1. So what I will do is add on a frequency density. Row. Here the frequency density is 1. If I look at the next interval, 5 to 20, we have our interval 5 to 20. The frequency density here is equal to frequency 45 divided by the class width, which is 15. So we have 45 divided by 15, which is equal to 3. So we have 3 for our frequency density. For the interval 20 to 40, we've got a frequency of 90, a class width of 20. So with that we can also find the frequency density. From 20 to 40, we've got the frequency density equaling 90 divided by 20, which is 4.5. So we've got a frequency density of 4.5 here. What about from 40 to 65? Well, 40 to 65, that's all of this area here. Now before we do anything else, what we can do is use the information here to add on our frequency densities. We know from 0 to 5 we have a frequency density of 1. We know from 5 to 20 we've got a frequency density of 3. So here we would have 3, and that means every big square is 1. So we've got 2 here, 1 here, 4, 5, and 6. So if I look at the interval 40 to 65, which is here, the frequency density you can see is 5.2. So we have 5.2 here, and with this we can find out the frequency by multiplying the frequency density by the class width. So if I focus on the interval 40 to 65, the frequency is equal to 5.2 multiplied by 25, which is equal to 130. So we've got 130 for the frequency, and if I add this on, we've got 130 here. From 65 to 80, well, you can see the frequency density here is 4. So in a similar way, we can find out what the frequency is. The class width is 15, the frequency density is 4, and so for the interval 65 to 80, the frequency will equal 4 times by 15, which is 60. So we have 60 over here. And then from 80 to 90, I can read that off, that's 0.1. So I have 0.1 here. So when I come to complete the frequency, the histogram, from 0 to 5, I've got a frequency density of 1. So showing that we've got this over here. From 20 to 40, I've got a frequency density of 4.5. And that's all I need to show. Now for part B, we have to use linear interpolation to estimate the median age. Now, before we do anything else, what we can do is find out the cumulative frequencies. To find out the cumulative frequencies, I start off with 5. 5 plus 45 is 50. 50 plus 90 is 140. 140 plus 130 is 270. 270 plus 60 is 330. And then 330 plus 1, that's 331. So now what I can do is find out the median. First of all, we've just found the total number of passengers is equal to 331. And with this we can find out the position of the median. The position of the median will equal 1/2 multiplied by 331. So we want the 165.5 value. So which interval is the median going to lie in? Well, if I look over here, we've just got 165.5 for the position of the median. So the median will be in this interval over here. And so the position, the median is in the interval 40 to 65, as we see here. So now what we'll do is use a line and then the gradients of the line to help us find out the median. So if I draw a line from here, well, if I go back, I've got 270 with 65 or less, and then I've got 140 with 40 or less. So if I use these limits, we've got 65 and then 270. Here I've got 40 and then 140, and then here I've got Q2 and 165.5. So now if I use the fact that the gradient of it on a straight line is equal, we've got Q2 minus the 40 divided by the 165.5 minus the 140. This is equal to 65 minus 40 divided by 270 minus 140. I need to find out what Q2 is. So if I find out what Q2 is, we have 65 minus 40 divided by 270 minus 140 multiplied by 165.5 minus 140 plus 40. It turns out I get 44.9 given to three significant figures. Now for part C. An outlier is defined as a value greater than Q3 plus 1.5 times the interquartile range, and given that Q1 is equal to 27.3 and Q3 is equal to 58.9, we have to determine, giving a reason, whether or not the oldest passenger could be considered as an outlier. So before we do anything else, we can find out the upper outer limit. The upper outer limit is equal to 58.9 plus 1.5 multiplied by 58.9 minus 27.3. So this is the interquartile range, this is the upper quartile, and if I work out what this is, 58.9 plus 1.5 lots of 58.9 minus 27.3, I get 106.3. And this is greater than, go back here, than 90, which is our upper limit. So this is greater than 90. So what can we conclude from this? Well, the oldest passenger is not an outlier. Question number 3. Helen is studying one of the qualitative variables from the large dataset for Heathrow from 2015. She started with the data from 3rd of May and then took every 10th reading. There were only 3 different outcomes with the following frequencies. For outcome A, we've got a frequency of 16. For outcome B, we've got a frequency of 2. And for outcome C, we've got a frequency of 1. For part A, we have to state the sampling technique Helen used. Well, what she did over here was she started taking data from the 3rd of May and she took every 10th reading. So what can we say from here then? Well, we have systematic sampling, and that's because she's taking the 10th reading. In other words, she's choosing items at regular intervals. Now, for part B, we have to use our knowledge of the large dataset to suggest which variable was being studied and name the outcome of A. Well, let's think about what we've got here. First of all, you can see we've got qualitative variables. What are qualitative variables? Well, we have the option of cardinal direction, or we have the daily mean wind speed. Now, she's taking reading from the 10th of May, rather the 3rd of May, and the 3rd of May is not autumn or winter. Now, what else do we know? We know that there are only 3 different outcomes. What are the outcomes of daily mean wind speed? Well, the outcomes are either light, moderate, or fresh. And if we take a look at A, well, we've got 3 outcomes, so it's definitely going to be daily mean wind speed. And A, we've got lots of something from these 3. Well, it's the 3rd of May, it's not autumn or winter, so it's going to be quite sunny. So this will suggest to us that this 16 would represent we have lots of light daily mean wind speeds. So for part B, what can we say from here then? We have daily mean wind speed with A being light. Now for the next part of the question. Helen and George decided they should examine. George is also studying the same variable from the large dataset for Heathrow from 2015. He started with the data from the 5th of May and then took every 10th reading and obtained the following. Helen and George decided to examine all of the data. And that's quite important, the examining all the data. And they got the following results. We have to state what inference Helen and George could reliably make from their original samples about the outcomes of this variable at Heathrow for the period covered by the large dataset in 2015. So what does inference mean? That just means conclusion. So if I take a look at A, we've got 155 over 155 plus 26 plus 3, which is around 84%. So what can we say about this? If I look at what I've got here and here, you can see variable A occurs the most with around, it occurs about 84% of the time. So variable A occurs the most for this time period, around 84% of the time. Question number 4. A nursery has a sack containing a large number of coloured beads, of which 40% are coloured red. Aaliyah takes a random sample of 18 beads from the sack to make a bracelet. For part A, we have to state a suitable binomial distribution to model the number of red beads in Aaliyah's bracelet. Well, if we let the random variable r equal the number of red beads in Aaliyah's bracelet, then r is binomially distributed with parameters 18 and 0.14. 0.14 comes from the 14%, and she's got a sample of 18 beads. Now for part B, we have to use this binomial distribution to find the probability for the first part that Aaliyah has just one red bead in her bracelet. So for the first part of part B, we are looking for the probability that r is equal to 1. So if we go to our calculator, to the distribution sub menu, we have binomial CD. Rather, we've got a binomial PD. X is 1, N is 18, and P is 0.14. So it turns out I get 0.1940, etc. And now, at least 4 red beads. So for this, we are looking at the probability that r is greater or equal to 4. That's 1 minus the probability that r is less than or equal to 3. So we've got 1 minus. Now here I need to go to the binomial CD. I've got 3 over here this time. So I've got 1 minus 0.761, etc. And it turns out I get 0.238, etc. Now for part C, we have to comment on the suitability of a binomial distribution to model this situation. Well, we require P equals 0.14 to be constant, so we need a large number of beads in the sack to ensure that removing 18 beads does not appreciably affect this probability, then it could be suitable. Now for part D, after several children have used the beads from the sack, the nursery teacher decides to test whether or not the proportion of red beads in the sack has changed. She takes a random sample of 75 beads and 5 for red beads. Stating her hypotheses clearly, we have to use a 5% level of significance to carry out a suitable test for the teacher. Well, if we let the random variable x equal the number of red beads in the sample, then x is binomially distributed with parameters 75 and 0.14. Now the expected value of x will quite simply equal 75 multiplied by 0.14. So if I work this out, 75 times by 0.14 is 10.5. So what do we want to check over here? We want to see if the proportion of red beads in the sack has changed. So the proportion is of course talking about P. So if I let my null hypothesis H0 have, with our null hypothesis, if you have P equals 0.14, then our alternate hypothesis H1, we would have P does not equal 0.14. Now the 4 over here is less than the expected value, so we need to look out for the probability that x is less than or equal to 4. So if I work out what this is, we need to use a binomial CD. So we have 4, 75 and 0.14. It turns out here we've got 0.01514, or 6, etc. And this here is less than the 0.025. We've got a two-tailed test, remember? And so what can we do here? Well, what we can do then is reject H0, and if we reject H0, that there's evidence to suggest that the proportion of red beads has changed. Now for part A, we have to find the p-value in this case. In other words, we need to find the actual level of significance. Now that's going to equal the 0.01506 plus 0.01506. We've got a two-tailed test, which is why I add those together like that. So I've got two lots of this, which is 0.03 or 1, etc. Question number 5. Two bags A and B each contain balls which are either red or yellow or green. Bag A contains 4 red, 3 yellow and n green balls. B contains 5 red, 3 yellow and 1 green ball. A ball is selected at random from bag A and placed into bag B. A ball is then selected at random from bag B and placed into bag A. The probability that bag A now contains an equal number of red, yellow and green balls is P, and given that P is greater than 0, we have to find the possible values of n. Well, what could I do here? Well, if I take a red out of A, that means I've got 3 red remaining, and then here in B I've got 6. Then what I'm doing is I'm taking out a counter from bag B and putting it into A. Now if there's 3 yellow and 3 red, we've got an equal number of red, yellow and green once we place a ball from B into A, which means I end up with 3 over here. So that's one option. We have 3 of each colour. So let's just write that down. So because we start off with 4 red and 3 yellow, we must end up with 3 of each colour. That's one option. There is another option. Let's suppose I take out a green from here. So then here I end up with n minus 1, and then add it onto here. So if I add that green over here, that means instead of having 1, I've got n plus 1 here. I could then take a yellow out of here, so I've got 2 yellow left, and that means here, if I take out a yellow from here and place it into A, I end up with 4 red and 4 yellow, which means that I have 4 green remaining once I take that out. So what else can we see then? We could end up with 4 of each colour. So there's 2 options here which we've just discussed. We can either end up with 3 of each colour or 4 of each colour. Now let's take each of these separately. So if we have 3 of each colour, that means first thing we did, we took a red from A to B, so that means we've got 3 red now in A, and then we put a green from B into A because we've already had 3 yellow, so now there's 3 green in A. Now if there's 3 green now in A, that means we've added 1 counter in from B to A, which means we started with 2 green in A, so then adding that 1 counter from B into A will end up with 3 green now in A, which means n is equal to 2. So now let's find out the p-value. So the probability that the first is red and the second is green, well, how many do we have? We've got 4 plus 3, which is 7, plus the original 2, so that's 9. And of those, 4 are red, and then in the other, we've got green B to A. So here we've got 5 plus 3, which is 8, plus the 2, so that's going to be 10, because we've already added 1 from A to B. So we've got 1 out of 10. So rather than here, this is 4 out of 9. So what have I worked out here? Well, here I've worked out going red A to B, and here I've got the green B to A. So if I work all of this out, I get 2 over 45. Okay, so what does that mean? It means n equals 2 and p equals 2 over 45. So that's one option, and the second option was when we had 4 of each colour. So let's just write that all those instructions down. So if we take a look at the situation for 4 of each colour, we can begin with 5 green because we take out the green. We said before, we take out a green from A, put it into B, and then we add a yellow from B into A, so we end up with 4 of each. So that's the combination we're talking about. So if we begin with 5 green, that means n is equal to 5. And then, after that, we take a green from A to B. So now we've got 4 green in A. And then, we take a yellow from B to A. So now there's 4 yellow in A. And we started off with 4 red anyway. So when we come to work out the probability that we've got the first being green and the second being yellow, well, we've got 5, which is green. And how many do we have originally? Well, we've got 4 plus 3, which is 7, plus 5, so that's 12. And then, second yellow, well, how many yellow do I have here? I've got 3, and then 5 plus 3 plus 2, because I've got, if I take a green out of A and put it into B, that means I've got 2 green now in B. So that means I've got 10 in total, and of those, 3 of them are going to be yellow. So I've got 3 tenths. So what am I working out here? Well, here I am working out a green from A to B. And here I've got a yellow from B to A. So what do I get? I get 1/8 in total. So what does this mean then? It means we've found n equals 5 and p equals 1/8. So these are my total. So I've got 2 options here. I've either got n equals 2 and p equals 2 over 45, or I've got n equals 2, or I've got n equals 5 and then p equals 1/8.